Hello, my name is Hee-Jin Ro. We would like to present our study titled Integrated Formalization for Temporal Referentials. The operation of applying an operator to an operand is used as a basis for applicative formalism. An operator is then considered as operating process which is associated in linguistics with incomplete linguistic units. In an enunciative theory, we explicitly differentiate clause from utterance, which enunciates it by means of taking charge operators. The function of a predicate is therefore the function of an operator, which must construct a clause from a certain number of arguments, its operands, which are either only terms or nested terms and clauses. We start from two approaches which necessarily appeal to the notion of operator: the theory of locative detection, the referential system. Using this formal theory and the theoretical approach, we present the abstract aspecto-temporal applicative scheme, which is an applicable form to any type of utterances in any natural language, containing all the necessary information. Therefore, we can formalize any utterance into the related applicative expression, which can be readable by a machine. Note that a computer program is a complex operator composed from more elementary programs. The idea of compiler must be started from the application system, that is, the applicative expression. Consequently, the abstract scheme that we present is the general formula in the domain of computational linguistics. The theory of abstract locative detection is an operation that generates a relation of utterances. This theory introduces three specific types or three specific relations of locative detection, which allow to generate different temporal relations: identification, differentiation, and rupture. In the domain of temporality, these three locative relations participate in the conceptualization of linguistic time and structure the various temporal referentials, including the enunciative referential, also called enunciative frame of reference. The locative detection schema X rep Y means that X is locationally detected with respect to Y. The symbolic notations are designated according to its means and use. The first generic symbol rep is used in the X rep Y schema to indicate a general locative detection, where X is identified with respect to Y and takes three values: identification, differentiation, and rupture. The second notation is rep ing for the identification of belonging, which is a sub-branch of the differentiation while keeping the characteristic property of non-symmetry. X rep ing-y means that X is identified as the ingredient or part of Y. We use it in our formalization to indicate that a temporal interval belongs to a given referential. The third symbolic notation, rep loc, is specific for temporal identification. This notation specifies the identification of localization, which is also a sub-branch of the relation of differentiation by keeping the characteristic property of non-symmetry. X rep loc Y means that X is located relative to the location of Y. The symbolic contains four locational values. First, concomitance between temporal boundaries. Second, the inclusion between aspectual values such as state, event, or process. And third, forward or anteriority between aspectual values, which means that one aspectual value is situated before another aspectual value. Finally, after or posteriority, for one aspectual value is located after another aspectual value. With this locative detection system, we can represent not only the relations of temporal boundaries, but also the relation between different referentials. Languages are systems of semiotic representations which can represent not only current situations directly perceived, but also past situations, targeted, imagined, possible, counterfactual situations. The different temporal referencing mechanisms are therefore one of the most essential fields of study in cognitive linguistics. Representations must identify different referentials, especially the referential of the observer and that of the fact described. In an enunciative approach, the enunciator becomes comparable to an observer who must organize what he observes and utters in a referential which contains it, and which has become detached from external referential, which is physical time, cosmic or calendar time. This ability to detach from the external world is one of the deepest abilities of mankind, and it is reflected in his language. A temporal referential, or also called the temporal frame of reference, is an ordered set of instants structured by the locative detection system, that is, the relations of concomitance and of differentiation. Each moment is identified in relation to at another time by these relations. A temporal referential can be also determined by a rupture relation from another referential. We define a temporal referential system as follows. For any instant of a temporal referential REF1, there is an instant t of another temporal referential REF2. Hence, this instant t cannot be identified by the concomitance or differentiation relation in the REF1. This instant t establishes a rupture relation with any instant t1 of REF1. It is necessary to consider in the modeling of linguistic time different registers underlying any aspecto-temporal reference verbalized in a text. An enunciative referential directly linked to the act of enunciation and the different referentials which are relatively independent of the enunciation but always linked by the relations of locative detection to the enunciative process. To account for the aspecto-temporal values observed in languages, we need different types of temporal referentials. First, the external referentials, which is also called external frame of reference (REX), and second, the enunciative referentials, which is enunciative frame of reference called REN, and third, referentials identified by the rupture relation with respect to the present utterance, such as RNA, non-actualization referential, or RPOS, referential of possible situations. A temporal referential can be determinate relative to other referential. The enunciative referential, designated by REN, is the first frame of reference. Through this enunciation, the enunciator constructs this autonomous referential detachable from the external world. In this constructed referential, the enunciator can specify the enunciative coordinates of the predicative relation that he takes charge and that he inserts in his enunciative space. This referential should not be confused with the external referential designated by REX, since the REN represents the point of view of the enunciator, while the REX can ignore it. Each enunciator builds his own enunciative referential. In the enunciative referential, the predicative relations are identified directly or indirectly in relation to the act of enunciation, which generates an enunciative process designated by pros J0. This referential is therefore organized by the enunciator and oriented from the fixed point T0. Also, the right boundary of the enunciative process coincides with T0, where T0 is the temporal mark of the unaccomplishment and is the first instant of the act of speaking, which is the act of enunciation. When an utterance in the form of predicative relation is presented in the REN, first, the act of enunciation is aspectualized in the form of an unaccomplished process, which is the enunciative process. And then the predicative relation is expressed by the enunciator in the form of one of the aspectual values, such as state, process, or event in the REN, or in another suitable referential in relation to the REN. The application scheme for the formalization of aspecto-temporal analysis, represented in the form of a liner or tree-based applicative expression, has become complex through the theoretical development of the utterances offered. The aspecto-temporal application scheme that we propose makes it possible to process a wide variety of utterances. It offers the possibility of taking on account of several predicative referentials, as well as the synchronization of referentials. The enunciator naturally takes care of all information, including temporal information. For an utterance represented in a certain referential REF, different from the REN, it is necessary to have a linguistic marker which allows the creation of a referential, and this marker, either an adverbial expression or a second predicative relation, itself becomes a benchmark interval in the REF. The following aspecto-temporal applicative scheme 1 contains all the information necessary for any utterance. In this general scheme, presented in abstract form, all the temporal conditions are distinguished into 4 subparts. The first part concerns information on the enunciation, that is, both the right boundary of the enunciative process being concomitant with T0 and the enunciative process belonging to the REN. The second part concerns the temporal conditions between the topological reference intervals, specifically a temporal condition between the interval of the aspectualized predicative relation 1 and the related interval I prime. And the interval I prime is situated in any type of referential REF other than REN. The third part expresses the relation between two different referentials, often with the rupture relation. The fourth part represents the synchronization, provided that if it exists, between the benchmark interval of REF and T0. We can also present the application scheme which is no longer in its simplified form but in its entire form. It is also possible to substitute the operator of taking charge by the enunciator plus J0, I say, by the enunciative operator enunce J0. For visual comfort, its representation in the form of a syntactic tree. Scheme 1 and 1 prime are the most abstract version of the development and complexity of the aspecto-temporal application scheme. With these schemes, we can formularize various types of utterances, even having one, two, or several predicative relations. We show briefly different types of utterances. The first type is an utterance having only one predicative relation situated on temporal axis of enunciator, that is, on the enunciative referential. If an utterance occurs in the REN, the information about the REN is redundant and implicit. Therefore, we can delete this information from REN to retain the relevant information. For the case of a simple utterance present in the REN, the scheme 1 and 1 prime can be simplified. At the right image is the simplified reduction of scheme 1 and 1 prime for a simple utterance, and at the left image is the representation tree of an utterance having a single predicative relation in the REN. The second type is an utterance including two predicative relations in the REN. If an utterance situated on the enunciative temporal axis contains more than one predicative relation, often two predicative relations, the notational and conventional simplification of scheme 1 and 1 prime trains again differently compared to the above case 1 of a simple utterance, because it is necessary to add information on the second predicative relation. First, we remove all the information of the referential REF and synchronization. However, we keep not only everything concerning the enunciative conditions, but also the temporal relation between two topological intervals. Second, given that the utterance is in the REN, we add, like the previous case of the simple utterance, an enunciative condition between the topological interval of the main predicative relation and the enunciative process. After these modifications, we show another linear form of conventional and notational simplification of scheme. The third type is an utterance identified in the non-actualization referential, narrative referential, which is also called RNA. For example, once upon a time, a beautiful princess lived in the magical world, or Julius Caesar crossed the Rubicon, etc. A fictive or historical narration is not part of the world realized by the enunciator, which is linked in the REN, and it is no longer identifiable in relation to the enunciative act, except for explicit indications indicated by synchronization. The narrative situation must therefore be inserted into another referential, the RNA. All we have to do is assign the value of the RNA to each occurrence of REF, and automatically the relation between REN and RNA is ruptured. The synchronization would take place if it exists, depending on the given context. For the other types of referential, their scheme forms would be identical to the form of RNA, giving different values of the aspect or of the referential and of synchronization. We argue that the notion of temporal referential appears as a necessity for a coherent conceptualization of the temporality apprehended by languages. A temporal referential is made up of instants identified by relations, either by identification or by differentiation. For the analysis of different utterances and even the text, different referentials must be taken into consideration, in particular the RNA for non-actualized situations, which are identified with respect to each other but independently of any reference with respect to their utterance. The RNA is thus constructed in a relation of rupture with respect to the REN. Certain analyses, like historical present or reportable present, for example, call upon a relation of synchronization between instances of two referentials, moreover in relation of rupture. By introducing these different types of referential into the aspecto-temporal analysis of utterances, we can lead to coherent analysis that are relatively simple and natural to the analysis undertaken by physics, biology, or psychology. This study on referentials is one of the major pieces of a general theory of aspecto-temporal representations in several languages, like French, Bulgarian, Russian, Polish, Korean, Arabic, etc. In summary, the main idea of a scheme is to deal with different types of utterance for computational formalization, because their applicative expression form is highly adequate for computing process in which all input units are operators applied to operands. Therefore, this scheme can ultimately help in the analysis of inferences as well as the implementations in an adequate functional programming language. We conclude that the concept of referential is the unifying concept. Temporal relations, concomitant or non-concomitant to the enunciation, and aspectual relations are all represented around the referentials. This unifying concept allows a conceptual economy because it cuts across the diversity of languages. It could be used to teach and to compare languages. The concept of referential is ultimately a function that makes it possible to analyze many natural languages. By reappropriating these presented concepts and theory, the abstract scheme can be applied to a computer implementation based on formalization and algorithm work. The computational implementation can deal with the concepts relating to notions of referentials, because using this abstract scheme, we can analyze utterances in the form of applicative expression which is readable in machines. Thank you for your attention.